Hope you're enjoying the conference. I certainly am. This is the I'm trying to remember the name of the title they gave this talk. It's a little different than mine, but Postgres at the center of your Dataverse, I think, was the cute little title. Mine's a little more mundane. But I think it's a really interesting talk because for me, this talk kind of sets the tone for where Postgres is going in the next 5 years. Postgres obviously spent a lot of time early on sort of becoming stable, having come from University of California, Berkeley students writing code and professors writing code, but eventually became obviously very stable. We spent a couple years adding SQL standard functionality to Postgres so that we are a very standard conformant database now. And then we spent some time in the past, say, 7 years working on enterprise features for Postgres, so making Postgres very performant and very a good fit for the feature sets that are needed in enterprises. But in the past 2 years, we've basically reached parity, I would say, in terms of enterprise capabilities. And we're now starting to go into a new direction, I think a direction that is going to play to the strengths of Postgres. It's going to be a case where Postgres isn't just copying the SQL standard or copying the enterprise feature of other databases, but is actually moving into a new direction, a direction where people choose Postgres not because it does what other people do, but cheaper or more reliably or open source or whatever, but actually does things that no one else does. And obviously, that's where you really start to hit the sweet spot of adoption. We're obviously, I think, probably 2 years into that. And I think this presentation does a very good job of explaining exactly what that is and what that looks like going forward. And I believe by the end of this talk, you'll have an understanding of sort of what it is that, what that vision looks like. And I think you'll see some echoes of things you've seen in the past 2 years come out, things that we're talking about adding in the next couple years, and you start to see sort of a trajectory of where the community's going. So before I start, just introduce myself. My name is Bruce Momjian. I'm one of the core team members. I've been working with Postgres for 19 years. I have been working at EnterpriseDB for 9 years, and of course, EnterpriseDB being a sort of enterprise solutions provider for Postgres users. And I do enjoy working there. It's a neat company. Most of my time is spent working on the community. I get to travel a lot. I get to go to a lot of conferences, which is kind of cool. And obviously, I get the chance to come here, which is also cool. I'm excited to have a San Francisco based conference because, of course, we have a lot of demand in this area. But it's a challenge to put on a conference in this area. There's a lot of costs, a lot of logistics. Unfortunately, Citus Data and the conference team have sort of threaded that needle, and I'm very excited about the outcome we have here. So with that said, let's get started. I will be taking questions as I go because I do have 55 minutes. So I think I'll be good about sort of stopping and sort of taking questions and getting feedback from people. This presentation is in 5 parts. The first part is really to talk a little bit about why Postgres is different than other traditional databases, particularly the object-relational capabilities of Postgres. If you've never heard of that before, hopefully that will, by the end of that section, you'll understand it. It primarily revolves about the ability of the extensibility of a database, which Postgres has unique capability for. The second is an example of that extensibility, particularly the work we've done in assuming NoSQL workloads. I'll talk a little bit about some of the history of how we got here and some of the technology that has driven this. The third thing, data analytics. We'll talk about some of the things that Postgres has been doing to sort of move out of the OLTP, beyond the OLTP traditional workload, and start to look at data analytics workloads. Again, similar to the way we've worked into moving into NoSQL type workloads. Fourth, we'll talk about database wrappers, foreign database wrappers. You would not think this is a fundamental sort of directional shift for the database, but I think once I'm done that section, you'll understand why I feel that this is sort of a really new area that has a lot of potential and is going to be very increasingly important as we go forward. And then finally, the idea of Postgres being a central data broker. Kind of when you put all these together, you start to see Postgres as not just a database, not just an OLTP database, but in fact something that starts to encompass all sorts of data sources together, NoSQL data sources, data analytics sources, foreign data wrapper sources coming from other databases, and the unique ability now for Postgres to act as a central hub for data activity. And again, I think that's a new strategic direction, and I think it's very exciting. In fact, the idea of this, the actual title, came from something Josh Berkus had said at a conference probably 3 years ago. So this sort of idea of Postgres as a central data broker, which is going to be threading throughout this presentation, I think is a sort of unique shift in the way that we do Postgres. Any questions before we get started? Okay. So let's look at number one. The first one, object-relational. What does that mean? That effectively means that unlike traditional databases where things like data types and stored procedure languages and index types and are basically baked into the binary. They're baked into the source code. There are assumptions made in the source code of what an integer looks like and what a float looks like, what a string looks like, and all sorts of other data types. Postgres was designed at Berkeley in the mid-'80s, started in 1986 by Michael Stonebreaker, as a post-relational system. In fact, the reason it's called Postgres is the idea that it's actually post-ingress. That's how the name actually came about. It's post-ingress, and it became sort of this Postgres. Ingress, again, being a database coming out of Berkeley in the mid-'70s. So what's really interesting about the design, and again, it's kind of interesting, is that everything is pluggable. I will tell you when I started with Postgres in 1996 that I disliked this feature. This feature was almost an unending source of bugs for us. When you're in the source code and you're looking at a particular data item, you can't assume it's an integer. You can't assume it's a string. You have to go look in the system catalogs to find out what it is and then sort of do different behaviors, and everything was abstracted. And it was a headache to really get this system working. And there was some discussion of just ripping it out as something that's just kind of a neat idea, but really was adding a lot of complexity to the system. We stuck with it, obviously. I don't think anybody seriously talked about ripping it out, but the idea crossed our mind a couple times. But what we have going forward now is a system that is easily extendable. Much more easily extendable than a traditional relational system. So if you think of the way relational systems like Oracle or DB2 add something to the database server, it's usually done in a fairly awkward kind of a bolt-on-the-side kind of a system. I get some nods sometimes from people who have experienced that, where when they're adding something, it doesn't quite work well with everything, and there's some gotchas about it, and it isn't transactional, you can't join to it, or it doesn't work with certain index types, and there's all these like these limitations. And that's normally because the system is hardwired to do certain things. Because Postgres is extendable, you have the ability to plug in a whole bunch of different behaviors in Postgres, and those actually work seamlessly rather than appearing to be a bolt-on. Okay. So let's look at an example here. This is the Postgres system catalogs. So I know it's kind of impossible to read, but again, you get the idea. By the way, if you're interested in these slides, and I should have mentioned that, you can download the slides from this URL right here. So no reason to take pictures of the screen. The slides are all up there. There's probably 30 PDFs up there, different presentations I've given, including recordings of a whole bunch of presentations. So again, that URL, if you just barely spell my name, it'll come up in Google. And then there's I've tried a whole bunch of different spellings, and it pretty much comes up. And again, under the presentations tab, this is where that presentation is from. So this is basically a a diagram of the system tables. And it's kind of hard to see, but basically you have things like operator to define operators, types which define types, proc which defines functions, cast, conversions, indexing, different things, inheritance. Basically the whole system, all those plugins are defined in the system catalogs. So let's take a look at an example here of an extension. This is a fairly trivial extension. If you've ever dealt with a book number, if you've ever looked on the back of a book, you see a number. It's like ISBN and has some digits to it. We have a contrib module called ISN right here. And if you install Postgres and you type that command in a modern version of Postgres, all of a sudden you get 8 or 9 new data types that didn't exist before you type that create command. Okay? And that's pretty cool. Now, you may not care about book numbers, but you might care about a whole bunch of other things that you can just add to Postgres by typing create extension and typing and loading that shared module in. And again, because the Postgres is extendable, all of these things work in a holistic manner. There's not a sense that like it's sort of bolted on or it doesn't look right. Here are basically, once they've typed this, they can now define columns to be of any of these data types, including ISBN, music numbers, a serial number actually is a magazine, article numbers, and so forth, and even UPC symbols. Okay, if you're curious about that, again, the URL is there. I said they look the same. They're not bolted on. If I'm in PSQL, which is the command line tool for Postgres, and I just type \T S, I get a whole list of data types, if any of you have ever done that before. And what's really cool is before I typed this, I only had the built-in data types. But after I typed that, all of a sudden I got a new data type. Didn't exist before. It looks just like integer, right? There's integer right there. It says integer. It's in the catalog schema, and it has this description. And probably right underneath it is something created in the public schema called ISBN and a description of it. So bingo, I now have a new data type. Real cool. How does this actually happen? We actually, as I said before when I showed you this diagram, we have a PG type table right here. And if you look at integer, which internally is called int4, 4-byte int, if you look at that in the PG type table, you actually see a whole bunch of columns that define an integer. How long is the integer? How long is int for? 4 bytes, right? I mean, again, it's way abstracted. Like you define how wide a data type is in the system catalogs. If you want to input an integer, you have to call a function. And you type int4 in, and that takes a string and returns an integer. If you want to output an integer, you do int4 out, and basically whatever you type, it gets sent out. Okay? So similarly, ISBN looks exactly the same. How wide is an ISBN data type? Who wants to tell me how wide an ISBN data type is? I'm sorry? You don't have to guess. 8. How did you know it was 8? It says it right there, right? Okay? The system catalog tells me, just like typelen says this is 4, then this typelen catalog entry tells me that ISBN type is 8. Okay? This is some of the headache you have when you're in the code, because all of a sudden you can't know something's an integer. You have to actually look. How wide is this thing that I have? It's always abstracted. And again, it becomes kind of a headache, but it's a good headache because of what it allows you to do. So here I've got a built-in data type int4. It has this type of entries. Here I have what appears to be an identically defined data type called ISBN. And I have an input-output function. ISBN in is my input function, and ISN out is my output function. Again, the input-output is slightly different here. That's OK. It has to do with the way you define, the way we have to do checks for ISBN. Again, this is a silly example. You probably don't care about it. But again, there's a whole bunch of other examples which are very, very powerful. So here's another example of extendibility. Most databases have one stored procedure language, right? Either it's PLSQL for Oracle, or it's T-SQL for Sybase and Microsoft. And DB2 has, I can't remember what it's called. It's not T-SQL. It's whatever it's called. So normally, a database has one stored procedure language. Postgres has like one default one, or two default ones actually, but it has a whole bunch of other ones. So what I've done here is instead of doing create extension to add a data type, I'm using create extension to add a stored procedure language. In this case, the stored procedure language is PL Python U, which is effectively stored procedures in Python. I could have done this for any other, a whole bunch of other languages. I have a list later. But again, I'm defining a new language. And if you take a look at this, you do a /D_L, you can see here's PL/PGSQL. That is the built-in stored procedure language, one of the built-in stored procedure languages in Postgres, the other one being SQL. And the second stored procedure language, which we've just added, is PL Python U. Okay? So here's a second example of us extending Postgres in a very clean way, in a way that works completely seamlessly with every other capability of Postgres. It does not appear as a bolt-on. I said there was a whole bunch of other stored procedures languages you could use. Here they are. Some of them are kind of shocking. PLSH always gets a chuckle from the group. PLTCL is one of our oldest. Of course, we have C and Schema, Ruby. PLR, super powerful for statistical analysis. If you see Joe Conway walking around, you have any questions about PLR, he's the guy to talk to. PL Python, I can't tell you why there's a period on the end of there. I'll fix that. PHP, there's the PL/PGSQL, and even Java as a stored procedure language. Although performance-wise, PL Java is not the greatest for memory consumption and startup reasons, but it is available. So again, you have a whole bunch of extensibility. The only one that comes in default with Postgres is PL/PGSQL and SPI. Those are the default ones, too. Okay? All the other ones are added as extensions. Indexing methods, and again, I recommend this URL if you really want to dive into this, but the idea of adding new indexing methods is not hard, is available in Postgres as well. If you've heard of SPGIST, if you've heard of GIN, GIN and GIST, these are all pluggable stored procedure language, stored indexing methods. As it turns out, they're installed by default, but it is possible to plug in your own if you really are excited about doing something like that. Okay. And if you thought I was lying, effectively we have a table called PGAM. It's PG_AM. It stands for access methods. That's what we call indexes. And if I just do a select from that, I can see all of my built-in index types. Okay. You might think that like something must be hardwired. Like, isn't a plus sign hardwired? No, no. So in fact, if I do a /DO_S, I can see that I have defined a plus sign for a case where two integers exist on both sides, and I have the plus symbol in the middle. And in fact, that function call actually calls this int for PL, and that actually defines what an addition does. So the idea of creating your own operators is also possible. We have a spaceship operator. It's like it's greater than dash less than, so it looks like a Star Wars, remember the old character games? We have a whole bunch of other crazy operators like @, and tilde, slash. I mean, there's a whole bunch of ways you can define whatever operators you want. You attach them to functions. Boom, you've got new operators. So like even the plus sign has to be defined in Postgres, which seems like craziness. But you start to realize that sometimes you want the plus not to operate on integers, but maybe on JSON or maybe on some other kind of data type where a plus sign makes sense, INET data types, or we use the plus sign actually to take a timestamp and add some days to it. So you have timestamp plus interval. If you've never played with that, it's super cool. So you can take like a time and say, I want to add 5 days, 3 hours, and 6 minutes to that time. Okay. Again, plus sign, it's not two integers. One's a time zone, and one timestamp, and one's an interval. New meaning for plus. Okay. There's other extensibility, casting, aggregates can be plugged in, so sum, count. These are built in, but you could add your own if you want to. Okay. But we also have external plugins. So PostGIS, I see Paul back there. Sort of, I would say, our flagship for extensibility. PostGIS, yeah, he's right there in the, raise your hand, there he is, great. So he's the person who I would say removed my embarrassing frustration about the extensibility system. Because until we had PostGIS, the extensibility system was just this lead weight around our legs, right? That effectively we were dragging through every release and make sure they kept working. But GIS took that away because it brought Postgres it allowed Postgres to be plugged into to do GIS things that we could never do on our own. And in fact, the whole GIS project was developed completely independent of Postgres. Okay, so that's kind of a game changer where you've got a whole field of computer science and analysis that is plugged into a database that knows nothing about it. And I think over all the years that they did that, there's only a handful of things they even asked for. Maybe 3, I don't know, where they said, oh, it would be nice if you could do this. I'm like, oh, okay, sure, right? But again, the idea that there's a huge connection between the two, or that we had to read jury thing to get GIS to bolt onto the side, never happened because of the way it was designed. Thankfully to Michael Stonebreaker and the design team. PLV8, the V8 is the JavaScript engine from Google. Again, if you want to run JavaScript in Postgres, you plug in PLV8. Again, completely independent project, has no connection to us. They just use the standard API. And again, just like Python U showed up, PLV8 will show up. And it'll run just like all the other stored procedure languages. There's some other things, experimentation that people have done. Full text search originally developed externally. There's just a lot of cool stuff that, and again, it doesn't seem like a big thing, but once you get to the end of the talk, you'll understand why. We also have some offshoots of Postgres, which again extended Postgres at the source code level. I'm sorry, I don't have CitusDB here. This was written before you guys were active, but that would be a natural thing to have here. But again, you've got a whole bunch of people who have taken Postgres and modified the source code. Not so much extensions or plugins, but in fact just took the code and changed it. Right? This is kind of a chart of, again, this you would go if you want to actually read it, but a chart of all the offshoots and where they've gone and where they've come from and where they've gone actually. So plugin's not a bad word with Postgres. That API that we have is fundamental to what Postgres is and what Postgres does. So again, just to reiterate, the idea of extensions are basically the ability to take externally applied modules, PLR, PostGIS, ISN, and just add them seamlessly to the database. Any questions? Wow, OK. Must have done well. OK, so let's take a look at the next thing. So I talked about Postgres as morphing, as taking on additional workloads. NoSQL, I think, is a poster child for this. Of course, NoSQL driven by a whole bunch of requirements of what people wanted to do with a database that relational systems couldn't do. Most relational systems are fairly rigid in how they do things and are very hard to change. Again, I've sort of reiterated the bolt-in feeling of a lot of the relational systems that do try and change. Okay, but NoSQL is a whole bunch of things. It's key value store, it's document database, it's columnar, it's graph. I'm just going to talk about the first two mostly, but effectively Postgres has the ability, because of that extensibility, to very seamlessly be changed to take on some of these new workloads. Why are these new workloads important? Because there are a certain class of applications that really are focused not on sort of traditional OLTP, but are really focused on very fast, simple queries. All right. Martin Fowler has a presentation. I don't think I linked to it here, but it's on one of my other slides, where he talks about the idea of NoSQL being an aggregate-oriented storage method, where instead of dispersing everything like we do in SQL, where we just take something and we atomize it into all the tables that it applies to, aggregate-oriented storage is where we just go in big blob. Everything about the customer is in this big blob, or everything about whatever transaction you're working with is this big blob. You just want to throw it in the database and you just want to get it out. Now, that's not really traditional SQL, not really traditional relational, but Postgres can do it. We're going to explain how. Auto sharding, that's another thing that a lot of people, again, one of the key issues in NoSQL. That's actually something we don't do too well, although we are working on that. We had a meeting in Vienna 2 weeks ago to talk about sharding. We have sort of a website up, and we have a to-do item, and we have EnterpriseDB, NTT, and a couple other companies, Postgres Professional, out of Moscow working on auto sharding. And we have some external sharding projects like Postgres XC, Postgres XL, that are being worked on by companies like Second Quadrant. So we're actually kind of working in that area, but really the watershed for Postgres was the ability to store SQL, store NoSQL type of workloads. But you're not only storing NoSQL type of workloads, but you're not bringing in the disadvantages. There's a lot of disadvantages because most NoSQL systems don't have a powerful query language. They don't have an optimizer. They don't do joins. They don't do referential integrity. Durability is sort of a hit or miss that you've got to keep an eye on. And again, makes these NoSQL systems usually difficult to report, hard to design. But NoSQL is kind of cool. So it's great if you need to do massive write scaling. And if you have a very simple API that you know is not going to change, you don't need a lot of transactions. But again, being able to do both, being able to do relational and NoSQL type storage, that's kind of great because you don't get the disadvantages of the very simple API. You don't get the disadvantages of the difficulty to run complex queries. You have sort of the best of both worlds. And that's actually one of the things that Postgres sort of was able to do when we got involved with doing JSON. So JSON or JSON-B, which was introduced in Postgres 9.4, really was a game changer in terms of the ability of Postgres to store NoSQL type of data, particularly JSON data. So as you can imagine with Postgres, again, the data types aren't predefined, the operators aren't predefined. So when you want to add something like JSON or JSON-B, all you really have to do, well, that sounds really trivial, but you have to basically create an extension or write something that works inside of Postgres that defines the data type, that defines the operator behavior, and so forth. And you implement that as a patch, you get into Postgres. And we had JSON in Postgres 9.1. We've improved it every release since. And you're looking at Postgres 9.4, where effectively you can do things like create a JSON field. You can effectively store a JSON document in there. And then you can even do queries, SQL queries, using JSON key lookups and comparing them to JSON values. Okay. What's exciting about this is not only does it give you the best of both worlds, not only allow you to store unstructured data, JSON data, in a relational system, but in a large number of cases, it actually performs faster to do this in Postgres than it does in a traditional NoSQL store like Mongo. And that was a real game changer for a lot of people. I was in Dublin when the Russians, 2 years ago, the Russians had just developed JSON-B, and they were running some benchmarks and in the hotel the night before, and they basically got up, and Alexander Kuratov, who was sort of the lead for the JSON indexing, and Theodore Sigayev, who did the JSON-B data type, were basically up there, and Alexander gets up and he shows a graph of Postgres performance compared to Mongo for a typical workload, and it shows Postgres being like, I want to say like 10 times smaller indexes and 100 times faster. And the Mongo index only can index one JSON key, whereas the Postgres index indexed every key. So you're like, I've got an index that just doesn't index one key, but index all of them, but it's 10 times smaller and 100 times faster. Like, how does that even add up? Like, what, is Mongo have like a sleep loop in there? Or, it was embarrassing, and I assume Mongo's improved it, although even in Mongo 3, I think there's still, I think it's still Postgres' game. But it's very rare for somebody to put up a chart and the audience to just go into applause. You know, I mean, that was the type of game-changing thing that we had there when somebody said, we can take Postgres' data type system, we can take Postgres' indexing system, particularly the GIN indexing system, and we can build something better than a database that just does JSON. And you're like, wow, that's pretty amazing. Obviously did a lot of good for us and sort of put Postgres in the cool category, I think, to some extent. But it was big. It was big. So this whole idea of Postgres doing NoSQL workloads, I think, is really powerful. Does it do everything NoSQL does? No. I think NoSQL really does well if you're using multiple servers, if you need to do sharding. We don't have sharding yet. We're working on it. But again, if you need that, that maybe NoSQL makes sense. But a lot of deployments are running Mongo on a single server, vast majority. And for those cases, it's sort of like you've lost all of the relational, efficiency, all the development efficiency, all the administrative efficiency of a relational system, and you've gained very little. I would say almost nothing, because again, it's not going to be smaller, it's not going to be faster in a single host on Mongo. Obviously, Mongo has some ability to expand that Postgres currently does. So there's some reasons for that. So there's some value to that. But when people are making some decisions saying, oh, NoSQL must be faster, well, not necessarily anymore. And that really kind of turned the tables. And again, an idea of Postgres going into new data. Another thing, the ability to change schemas online. Postgres has always been very good with that. Even the ability to change schemas while you're in a transaction. So here's an example of a rename and two add columns inside of a transaction block. And again, DDL in Postgres is atomic. So the changes to the schema happen atomically. They don't happen, it doesn't commit a transaction after every DDL like some database does. It basically waits for that transaction to commit, and then that entire schema change becomes visible in one case. Okay. Any questions? No questions from that one either, really. Surely someone must have a question. Okay. I'm not going to force you. All right. So let's take a look. Let's take a look at data analytics. Again, following on the theme of Postgres being extensible and Postgres kind of moving into new workloads, data analytics typically is not what an OLTP system does. Normally, data analytics is something you buy a special data analytics database for. But again, because Postgres is extensible and because it has a very nimble development community, we're able to move into not only NoSQL workloads fairly efficiently, but actually into data warehouse workloads efficiently. So if you look at every release of Postgres over time, you can see that there have been improvements in data warehousing in pretty much every release. Even in the 9.5 release there, the last two indexes, the last two bullet points, this min-max indexes is actually now called BRIN indexes, the BRIN indexes that we have coming in Postgres 9.5, which allow you to basically index every column of your database with very tiny indexes. It only records the min-max for typically a megabyte of size of table. So you scan the table. For every megabyte, you record the min and max, and then you store that in a little tiny table. And when you're kind of wanting to go, I want the number 12, well, 12 has to exist between the min and max for you to look at a block. So it allows you to skip a whole bunch of data that you know couldn't possibly have a 12 in it, and to basically scan only the 1 meg chunks that could potentially have the value you're interested in. Again, this is not a replacement for B-tree or any of the other indexing types. It's really a case where you want an index, you don't know if you're ever going to use it, you don't mind, the table's very large and you want a very low overhead, something that doesn't require a lot of maintenance when you do an update or an insert. and Brin indexes are really good for that. Grouping sets, cube and rollup, again, something also coming in Postgres 9.5. These are very traditional OLAP type of analyses. Yes, Peter?
Yeah, the min-max integrated time series data.
Yes, that's a great point. I do have a presentation on my website. It's not listed here, I'm sorry, that talks about the Postgres 9.5 features. And I believe number two, it's on the same URL before. Number 2 actually talks about the Brin indexes. And you are correct. It's particularly useful if you've got append-only tables, because typically append-only tables, the data is going to come in sort of batches that have similar min-maxes that are sort of distinct from the rest of the min-maxes. Again, mostly time series if you're lucky. And then you can scan stuff really quick and say, oh, it can only be in this meg and this meg, and the rest of the terabyte of data I don't have to look at. And that's really where this kind of thing makes a lot of sense. Yeah. If you put a B-tree index on every field of a table, inserts are going to be slow, updates are going to be slow, the indexes are going to be huge. It's just not, you're not really, you have to be really selective of what you want to put in a normal B-tree index on. But the Brin, you can just sort of throw it out and hey, it's fine. Even how often are you going to do an insert that is bigger than the min and max? Probably very rarely, right? So you don't even update it when you're doing inserts and updates. Most of the time that Brin index never changes. Grouping sets, again, that's actually number 3 on my top 10 9.5 features. But again, really good for analysis, things like doing aggregates of multiple groups. So if you want total by department and total by the office and total by department office combination or something like that, that's what you'd use that for. We've added things like common table expressions, materialized views, data partitioning. We're working on parallelism. We've got parallel sequential scan coming in Postgres 9.6. Again, these are all like super sort of data warehouse type of needs. And we see ourselves going kind of seriously into that space. We've been able to do it very seamlessly with very little overhead. So I'm kind of happy with the progress we've made. Are we really ready to take on a Teradata? No, we're not. It's more of a case where you're already doing OLTP and you want to do some data analytics on it. I think once we get sharding and once we get better parallelism, which again we've just started to get in Postgres 9.6, that will change. That will change. You'll start to see Postgres, with tens or hundreds of servers in a cluster. You'll start to see Postgres be able to do parallel. We already can do parallel sequential scans in 9.6, but again, things like parallel joins, parallel aggregates, parallel scans of partitions, the ability to do PostGIS function calls in parallel, right, which we've talked about. That's labeled under expensive functions, and I think PostGIS is an example there is a parallelism to wiki, which I kind of maintain occasionally, and so you're probably looking at 2 or 3 years until Postgres is really, I would say, on parity with some of the dedicated data warehouse systems. But you can already do quite a bit with it, and we are going to be able to do more and more as we move Postgres forward. Again, a great example of Postgres kind of seamlessly moving into other areas without having to bring in a whole lot of warts, without having to bring in a whole lot of weird APIs or things that don't work or destabilization problems or needing a special version of Postgres to do data warehousing. That's just not really the way we go, and I've been very happy with the progress. Another capability which we've had for a while is the ability to have data warehousing happen on a slave. So getting your data warehouse workload off of the main machine. Obviously, the use of streaming replication makes that possible. You can run all sorts of data warehouse queries on your standby while your master does things. So Postgres is not going to be as fast as a lot of the dedicated data warehouse systems, but a lot of people say, hey, I can run it on my standby. I don't really care. It's not going to slow my main production server down. If it takes an extra 5 minutes, that's not a big deal for me. So again, you can see Postgres moving more into that. And again, once we get more parallelism, once we get more sharding, that calculus will change, and Postgres will be much more of a drop-in replacement for a lot of the dedicated data warehouse systems. Okay? Questions? Wow. Peter, so long, you're the only guy who's answered the question so far, so yay. Okay. I must be doing really well or really poorly. Okay, so number 4, foreign data wrappers. Again, I told you in the beginning, this is going to appear like, ho-hum, why is this a game changer, right? The reason this is a game changer is because it allows Postgres to do what it does well, and it allows you to store your data in other places where Postgres does not do well. I'll say it again. This allows you to store your Postgres data where Postgres does well, and to seamlessly store your data that Postgres doesn't do well somewhere else. Okay? So if you need a network database, which Neo4j is, okay, a graph database, and Postgres doesn't do that certainly as well as the dedicated Neo4j. Although I just realized that Mongo we're better than Mongo. So maybe we are better than Neo4j. I don't know. Nobody's ever done numbers. Does somebody know? Is it great? What's this? We're terrible. Okay, great. We know we're terrible. Good. So that's definitive. So if you need graph-style storage, you can store it in Neo4j, and you can use your foreign data wrapper to go into Neo4j, do whatever graph stuff you want to do, bring it back into Postgres, do whatever joins, aggregates, manipulation you want to do, and return it to the user. We can even take Neo4j data, we can join it with Oracle data, and we can go and find a Twitter feed that matches, and then sort of join them together and sort of spit them out at the customer, even though they won't have no idea what we just did. So the idea of being able to use Postgres as a central data broker for things that we don't do well, CouchDB, again, a good example. CitusDB, a good example, where columnar store, you want to store log data, something that compresses very well. Again, Postgres doesn't do that compression, cross-row compression very well. Columnar databases, that's what they're designed to do. So you can use those stores, store the columnar data with the compression in these data stores, but then you have full access from Postgres. Let's see what that looks like. You could also use JDBC, LDAP, ODBC. Again, you don't even have to use one of these databases. Anything that understands JDBC, you can get to from Postgres. You can go to files. You can get data off of Amazon S3. I already mentioned you can get data off of Twitter. So what does it look like? Here's a super simple example. And I'm sorry it's a little small on the screen. But effectively what you do, and this is a connection from one Postgres server to another, so very trivial. I do create server, Postgres FDW test. I create a foreign data wrapper with the same name, and I define how to connect. And then I create a user mapping, which in this case is completely useless. And then I create a foreign table, which says on the foreign server, the table is called world, and I want to call it other world on my server. Okay? So I know I talked about all these other places you can connect to, but for the example, I'm just connecting Postgres to Postgres. Okay? And effectively, what we have here is when I go to get a list of tables, now other world appears as a local table to me, even though it is a foreign source. In this case, it's a foreign Postgres source, but it could be a foreign Oracle source. It could be a foreign CitusDB source. It could be a foreign CouchDB or Neo4j or whatever, or a foreign JDBC source, or a foreign HTTP source. I know it's kind of weird. Like you can go out in the web and pull data out and join it, as it opens up a whole bunch of possibilities. Okay, so again, the idea of Postgres sort of being central, the idea of Postgres effectively being able to not only get data from foreign sources, but to store data. Most of these foreign data wrappers are read-write. So like the Oracle foreign data wrapper, you can write into it and you can read from it. I think that's true of the Mongo one and a bunch of others as well. Certainly the Postgres one. You can, not only can you read data from those foreign sources, you can actually store data into those foreign sources. So a lot of these aren't very good in terms of analytics. They aren't good in terms of storing relational data. So the cool thing is you use these foreign data sources, what they're good for. you bring them back to Postgres, you do your analytics there, you do your relational, you do your joins there, and then you can bring it back. Okay? So again, the idea of going out to a foreign data source, either reading or writing, is certainly a unique capability of Postgres, and I think something that is sort of a game changer for us. Okay. Questions? Yes, sir.
Let me see if I understood correctly. If the backend doesn't have the ability to do filtering and say filtering and sorting, could I leverage the Postgres filtering and sorting capabilities?
Okay, so the question is, if you're connecting to a foreign data source that doesn't have some facility, whether it's sorting or where clause or joins or whatever, can you do that and then bring the data back and do the work in Postgres? And that's absolutely true, and in fact, I think one of the foundational issues of what you can do with Postgres. So, for example, if I want to do analytics, right? I don't know MongoDB very well or many of the relational stores, but I can pretty much guess that their analytics capabilities is pretty poor, right? Because they just don't have the language, they don't have the, this wasn't designed to do this kind of work, okay? So a lot of people who need analytics work on some of these systems that don't support it effectively will pull the data out of these foreign sources that can't do analytics, do all the analytics as though it was a local table, even though it isn't, and then return the data to the user. So in fact, the ability to, and I glossed over this, but the ability to what we call push things to foreign sources is data wrapper specific. So for example, if you do a where clause against the other world table, that where clause will be pushed to the foreign Postgres server, okay? Because the foreign Postgres server understands how to process a where clause. If you do the same query to a file has no idea what a where clause is. Certainly Amazon X3 or HTTP don't. So in those cases, the entire result's brought back, and the where clause is applied on the Postgres server. Okay? So not only can you do analytics locally and bring the data over, but you can do even things like joins and where clause and so forth. In fact, I think one of the other game changers I haven't really gotten into here is the use of the foreign data wrappers to do sharding, which I alluded to earlier as Postgres in the data warehouse and moving to a sharding architecture where we have a central broker, a coordinator, and then a bunch of shards where we shard our data across multiple servers. The communication method, one of the possible communication methods, getting data from the coordinator to these shards is the foreign data wrapper interface. Now, whether that becomes true or not, we don't know, but we're actually having, based on the meeting we had in Vienna, we have sort of approval to do a proof of concept. So we're going to improve the foreign data wrapper system. So not only can you push where clauses to Postgres, you can push sorts to Postgres, and you can push joins to the Postgres foreign data wrapper. And we have, again, EnterpriseDB, NTT, and Postgres Professional out of Russia all kind of working on that idea. We're not really sure how it's going to perform. It may be great, it may not. But we know we need to be able to push stuff more than where clauses already to these foreign data wrappers. So we're going to improve foreign data wrappers to push joins and sorts. Okay? Then we're going to take the parallelism work we're having. We'll allow parallel scans across partitions, parallel scans across foreign data wrapper calls. So now all of a sudden you can have 20 foreign data wrappers, and you can parallel request all the queries to run simultaneously and get the results back. Okay? You take that capability and you add a transaction manager and a snapshot manager, and you're kind of done in terms of getting a proof of concept sharding going. Okay? So again, we're not positive how that's going to perform. We do have Postgres XC and XL. They have actually showed very good benchmarks as sort of proof of concept sharding solutions with a central coordinator. And I'm hopeful that we're going to be able to extend. I've talked about extending Postgres to NoSQL in a sort of holistic way, right, without feeling like a big jolt. I talked about moving it in data warehouse in a very elegant way, you know. And I'm hoping that by enhancing foreign data wrappers, as I'm seeing here, parallelism and then adding a snapshot transaction manager, we'll be able to sort of move into the multi-cluster, the clustered Postgres data warehouse space with sharding in the same kind of unified way. Okay, now that's something I really didn't cover, but again, it's sort of a hot topic this season because we're trying to get approval to kind of move in that direction, and Citus data people are helping us out. They have some experience in trying to use foreign data wrappers as well. So it's going to be a year, I'd say, to proof of concept for customers, and probably 2 years to production. But I think this is again an area where foreign data wrappers are going to be pretty key in allowing Postgres to morph into something more than it currently is. And finally, effectively, we have the conclusion. The idea that Postgres, being an object-relational system, can take on NoSQL workloads, can take on data warehouse workloads, can allow you to access foreign data sources very seamlessly, brings it into basically a new capability where Postgres now sits at the center. You have the ability to do NoSQL. You have the ability to reach out to other data sources. You have the ability to do data warehousing. This brings Postgres really into an area that no other database has been in. I've talked about sort of the history of Postgres and the history of Postgres development. And honestly, when Postgres is copying the SQL spec or copying what other databases do, we can do that. But what we really do well is innovation. Open source, unlike commercial companies are really bad at innovation. There's too much overhead. There's too much inertia in most commercial companies to do any kind of major large companies, major kind of innovation. Usually the only innovation they can do is they got to buy another company to get innovation into their company. Unfortunately, historically, that's the way it's worked. And Postgres, as an open source community, obviously doesn't have the same infrastructure, the same overhead, or the same inertia. We've been able to sort of implement the SQL spec and implement enterprise features. But what we really do well is innovation. So I think if you look for the past 2 years, I'd say we're in that new era of innovation. You see things going into Postgres that no one else has. You see Postgres doing things faster and better than any other solution out there. And I think that's just going to continue. And I think that's part of the reason we're having this conference. That's part of the reason that there's so much buzz around Postgres. That's one of the reasons there's just been so much activity in the past couple of years is because now people are not choosing it just because it does what everyone else does. It's now innovative. It's now doing new things. And I think that's only going to accelerate going forward. I think we have many, many exciting years ahead, I think because of that, where we're now really going into our sweet spot, our case where we're really playing to our strengths. And if you view how the community works, how new ideas come in, how we interact with users and get ideas and implement those, I think you're going to find that that's generally true. Any questions? I have 1 minute. Yes, sir. Yeah.
What's one thing you feel is missing right now? Like, what should somebody either work on or?
The two things we're missing, and I've been harping on this for a couple of years now, is parallelism and sharding. Parallelism and sharding are the two missing pieces. Okay, so let me just finish. So you actually might. So years ago, the missing piece was the Windows port, and we did that. Then a couple years later, the missing piece was in-place upgrades, and I felt that was an issue. Certainly streaming replication was something that we needed. Logical replication we're getting now, and that has some groundbreaking flexibility for replication that we didn't have before. But I think going forward, it's looking like sharding and parallelism, and I think, fortunately, we're working on both of those pretty heavily, and I'm excited about that. Yes, Peter?
So I think neither of those speak to what you were just talking about as the strength of Postgres, which is this great innovation. There are lots of started and parallelized databases. Things that would not be hard, that would be anyone in this room could probably go start contributing to. Go pick up one of those foreign data wrappers, figure out how to do another kind of push down, figure out how to make those a little faster, figure out how to make those a little more efficient, fix a bug, improve the docs. Add some more data types it's not really like Ruby or another thing where you can kind of say like gen install. You have to do, someone has to build an apt-get package, so the packaging and release process for these things is Baroque and requires super user, so that's problematic. You could start looking at graph sort of, like, we don't need to become a graph database, but being able to query and represent tree data probably only requires one or two new executor methods and a couple of functions and operators to take advantage of them. This is all stuff that is relatively varying in size from an afternoon on the couch to like a year of hard development, but would all be interesting, relevant, and useful tomorrow if someone built it.
Great. And I'll close with that. Thank you.